Okay, so the last unit on, or the last section of this unit is solving radical equations. Radical equations. All right. So the steps are right there. Woo. Okay. So we just gotta follow them. Step 1, isolate the radical. Step 2, raise each side of the equation to the power of the index of the radical. Step 3, solve the resulting equation. If there are multiple radical components, do one at a time. Step 4, once you get some funny looking polynomial, you solve for it. Rational, I suppose you could, it happens. Solve for it, check the potential solutions in the original equation to make sure you don't have any extraneous behavior. Important note. You might, hear me out, be tempted to say the root, if square root of x is equal to -7, x is equal to 49. That is not true, because this insists on the principal or positive root. Okay? So, what I mean by that is, if root something is equal to some number, that number's got to be positive, because when we take the square root, we only take the positive root. Okay? Okay. So, let's do some examples. I think that's our best bet, all right? So, our first problem will be problem number 11 for the 6.7 exercise problems, okay? For those of you who might have a separate book, that's okay. I'll also write it out here, obviously, okay? Let's do an example. You have root x is equal to 10. All right, step 1, isolate the radical. Step 1, done. Step 2, raise each side of the equation to the power equal to the index of the radical. This is a secret too. Raise everything to the second. Square both sides, if you will. Square both sides, you get this. Please, 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 when you're squaring, parentheses. This only has one term on each side, but when you have multiple terms, bad things start happening. Okay, that leaves you with x is equal to 100. Step 3, solve for x. There are no other radicals, so we're done. Step 4, plug it back in. Root 100, is equal to positive 10. We're done. Let's do another one. We are going to look at number 13, which is root x plus 4 is equal to 6. Step 1, isolate the radical. Subtract 4 on both sides. Root x is equal to 2. Square both sides. X is equal to 4. Okay, plug it back in. Root 4, again, principal root, is equal to 2. We are done. Let's do a harder one. Let's do number 15. Let's get a new page. Let's do number 15. Number 15 is root 5y plus 1 is equal to 4. Note that the plus 1 is inside the radical, okay, my friends? Put the parentheses if you have a tendency to get lost, okay? Right, step 1, isolate. It's already isolated. Step 2, let's see, the root is 2. It's a secret 2, so we square both sides. We square both sides, you get 5y plus 1 is equal to 4 squared. 4 squared is equal to 16. Solve for the variable. Subtract 1, this is, standard polynomial behavior. 5y is equal to 15. Y is equal to 3. Step 4, plug it back in. The square root of 5y, which is 3, plus 1 is equal to root 15 plus 1, which is root 16, which is equal to 4. Okay, this one is not in the book, but it's important, and I'll show you guys why in a second. Ready? Let's say I want you guys to solve root x minus 1 plus 4 is equal to x minus 3. Step 1, isolate the radical. Okay, so we're going to subtract 4 on both sides, and that leaves us with root x minus 1. I'm going to highlight the radical so we don't lose it. If we subtract 4 on both sides, that gives us x minus 7. Okay, again, secret index, it's 2. Let's square both sides. If we square both sides, we get x minus 1 is equal to x minus 7 squared. Do not do this. Don't do that. Do not do this. Absolutely do not do this. Okay? All right? Okay. All right. Now this is just our run-of-the-mill polynomial things. X minus 1 is equal to, let's distribute, let's expand this. This should give you x squared minus 14x plus 49. Cool. Business as usual, subtract x on both sides. 1 is equal to x squared minus 15x plus 49. Yep, I did do that right. Add 1 to both sides. X squared, I'm going to switch the sides because I don't like x squared being, like our variables being on the right hand side. X squared minus 15x plus 1 is 50 is equal to 0. Let's factor this guy. Multiplies up to 50, adds up to negative 15. Factors of 50. 2, 25, 3, 4, 5, and 10. Okay, since this is negative, it's going to be minus minus. Okay. This leaves us with x squared minus 5x minus 10x plus 50 is equal to 0. All right. And then we say beep, beep, beep. We factor the x's out. We can kind of group it up like this and like this, right? And if you do that, you're going to get, factor out the x, gives you x minus 5 on the inside. You factor out the negative 10, and that gives you x minus 5 on the inside is equal to 0. Okay, now we have x minus 10 as your first factor, x minus 5 as your second factor is equal to 0, and your potential solutions are x equals 5 and 10. Any questions so far? Okay, are we done yet? No, we are not. No, we are not. We have to do step 4. This is why it's very important to do step 4. Okay, ready? You have two options. Do you notice how up to here, or like up to like here, we don't square? You can either plug your potential solution into here or here. It doesn't really matter because you haven't done anything weird quite yet. Like this or this, because you haven't done anything weird quite yet. I prefer doing it over here because everything kind of combined down additively, and addition doesn't do bad things. Addition and subtraction don't usually do bad things. Excuse me. But if you feel more confident, here is fine. Do not plug it into there. You've already squared things. Squaring does bad things. Right? Squaring does bad things because, you know, we go back to the, root x equals negative 7, x is 49. That's the negative root. Okay? So we plug this guy back in. We test, let's see. We're going to test x equals 5. And that gives me root 5 minus 1 is equal to 5 minus 7. Root 4 is equal to negative 2. Positive 2 is equal to negative 2. Now that ain't right. You don't believe me? It's okay. Plug it back into the original one. Like the original. Okay, fine. Root 5 minus 1 plus 4 is equal to 5 minus 3. Root 5 minus 1 is root 4 plus 4 is equal to 2. Okay, 2, positive root, okay, principal root, plus 4 is equal to 2. 6 is equal to 2. That definitely ain't right. Okay? Any questions about that? Right. Yeah, so the solution is what they call extraneous. Yeah, that's all. All right, now we have to check x equal 10. Let's do that. Let's plug into the original equation, just for the love of the game. Okay. Root 10 minus 1 plus 4 on the outside. Okay. The 4 does not belong under the radical is equal to 10 minus 3. 10 minus 1 is 9, plus 4 is equal to 10 minus 3 is 7. Root 9, positive root, is 3 plus 4 is equal to 7. That is true. So your solution, x is equal to 10. Your extraneous solution, x is equal to 5. The solution doesn't work. You have to label it, okay, my friends? On your exams, if you don't test your solutions, you're not getting full credit. I think that's fair. You're procuring solutions that shouldn't be there. You know what I mean? All right? So that's how you check for extraneous solutions as well. Let's do a multi-radical problem. Oh, also it's worth noting, extraneous solutions show up when your index is even, right? Because the positive and negative behavior, they don't show up with odds. Okay, so like if like the cube root of 3 or a cube root of x is 9, and then you're like, oh, it's gonna be 9 cubed. Yeah, that's fine. All right, that's fine because you preserve the even and odd behavior for or the positive and negative behavior on an odd root. Okay. All right, let's do an example in which the root is not 2. Let's do a cute one. Ready? Let's say it's 2 cube root of x plus 1 is equal to 6. Ready? So, again, we have to isolate our radical. There's a 2 here. What's the operation? The operation is multiplication. So to undo multiplication, what do? That's right, we divide. So we divide by 2 on both sides. That gives you cube root of x plus 1 is equal to 3. Any questions? No? Okay. Now it's isolated. We've done step 1. We're going to raise both sides to the power equal to the index of the radical, which is 3. It's because of this, not because of this. Okay, I shouldn't have chosen 6, but it's okay. All right. Raise to 3 to cancel out this, right? So this is going to look like x plus 1 to the third is equal to 3 to the third. Again, this is raised to the third because it matches the index, not because it matches the constant, okay? Right, raise both sides to the third. That gives me x plus 1 is equal to 3 to the third is 27. Okie dokes. Subtract 1 on both sides. X is equal to 26. Of course. Check your solutions anyway. Even if it's not extraneous, you might have goofed up. It happens. Happens to the best of us. We check our solutions. So you say 2 cube root of 26 plus 1 is equal to, what is it equal to? This is 2 times the cube root of 27. Cube root of 27 is 3. 2 times 3 is 6, and we are done. Always check your solutions, even if you're raising to an odd power, because you could still mess up. Okay? Okay. Now, let's work on multiple radicals, all right? All right, let's do problem number 47 on your practice problems, okay? And that one's going to look like the fourth root of h plus 4 is equal to the fourth root of 2h minus 5. Luckily for us, it's already isolated and the indices are the same. We raise both sides to the fourth. That's going to look like this, okay? And that leaves you with h plus 4 is equal to 2h minus 5. All right, this is a polynomial. This is easy. We subtract h on both sides. H minus 5. Right. subtract 4 on both sides. 0 is equal to h. Sorry, not subtract 4. You don't need to do all that. Add 5 to both sides. 9 is equal to h. Check your solutions. You're going to say the fourth root of 9 plus 4 is equal to the fourth root of 9 times 2, which is 9 times 2 like that, right? Okay. I don't know what the fourth root of 13 is, but that's okay. Oopsies. But that's okay because you can just compare the left and the right hand side like this. 9 times 2 is 18. 18 minus 5 is 13. Who cares what this number is because they are the same number. Yeah? Yeah? Okay. Let's do a harder one. Let's do 49. Actually, you know what? I want you to do number 49. You do number 49. And send that guy up to Gradescope. And that one should look a little like this. Do number 49. Send it up to Gradescope for me. Okay, now let's do a couple of multi-radical ones together. Again, once you've done one, you've done them all. Let's be so for real here. Let's do number 50 together. Number 50 is going to be the cube root of k minus 8 minus the cube root of 4k plus 1 is equal to 0. Okay, step 1, isolate. Cube root of k minus 8 is equal to the cube root of 4k plus 1. If you want to write this as a fractional exponent, go crazy, okay? All right, I'm going to raise everything to the third. K minus 8 is equal to 4k plus 1. I'm going to do some isolating magic. This is going to be 3k, subtract like that, and then like that, is equal to negative 9. K is equal to negative 3. Let's hope I didn't mess that up. I'm going to plug it back in. I'm going to plug it in and we're going to say, okay, the cube root of negative 3 minus 8 is equal, minus the cube root of negative 12 plus 1. And this should equal 0, right? Let's work it out. This is going to equal the cube root of negative 3 minus 8 is negative 11 minus the cube root of negative 11, and that equals 0. And the cube root of a negative number is okay because of why? If you don't know why, please revisit the first video for this chapter, okay? All right, let's do, oh, it's a typo. Great heavens. Let's do, let's do number 54. That should be a minus, my friends. It's a minus. All right, so if we work that out, it should be, shuffle this bad boy over, root 3k minus 5 is equal to root 3k minus 1. Square both sides. And again, if they're mixed indices, just do one at a time. It's okay. They're not, these are the same index, but anyway. Square both sides. This gives me 3k minus 5 is equal to root 3k minus 1, the whole thing squared, right? And what does that equal? We know how this works. 3k minus 5. This is a squared minus 2ab plus b squared. So a squared minus what? 2ab plus b squared. Okay, we're going to shuffle some things around. Okay, we're going to whoop, whoop. All right, sorry, whoop, whoop. And that should give us negative 2 root 3k is equal to 3k minus 3k is 0. Negative 5 minus 1 is negative 6. Okay, that's okay. And we're going to divide by negative 2 on both sides because we can't just square it. That's not how that works, right? Divided by negative 2 on both sides, that leaves us with root 3k is equal to 3. I'm going to square both sides again. Oopsies. 3k is equal to 9. We're going to divide by 3. K is equal to 3. We're going to test our solution. I'm going to plug it right back into here, okay? You might want to label your checks so you know where to find it. Okay. Root 3 times 3 minus 5 minus root 3 times 3 is equal to 3 times 3 is 9 minus 5 minus root 3 squared, and that's going to equal 9 minus 5 is 4, root 4 minus 3, root of 3 squared is 3, right? Which is equal to 2 minus 3, which is -1, which is exactly what we wanted. That's it. That's how you solve radical equations. Yeah, thanks for your time and attention. Oh, I gotta give you guys work problems. Okay, so I want numbers 16 to 18, 23 to 24, 28 to 30, 42 to 44, 46, 49, and 65 to 67. Okay, and I will briefly, because I know some of you guys mentioned that the numbering is a little different, so I'll just briefly flash across the screen what each problem should look like. Feel free to hit pause, take a screenshot if you gotta. Yeah, and that is it. There are, I think, 2 more lecture videos, and we're done. Woohoo! And there we have it. All right. Good luck, my friends.